Welcome to another AgGateway Global Network video. I'm Jim Wilson, President of AgGateway Global Network, and with me is Andres Ferreyra with Ag Connections. Andres will discuss geopolitical context items. Andres, please tell us what you do for Ag Connections and AgGateway, and then move into your presentation.
Thank you, Jim. Hello, everyone. Thank you for attending this webinar. My name is Andres Ferreyra. I work for Ag Connections, Farm Management Information Systems company. And my role in that company is as manager of special projects to handle several of our integrations with different partners, and also to head our involvement with AgGateway, where I have been very active in the Precision Ag Council and its projects, Spade and Pale, as well as in the ADAPT and Standards and Guidelines committees. Today, we're going to talk about an idea that came from Spade project called the context item. So let's provide a little bit of background first. Precision agriculture is still limited by a series of interoperability problems. Different kinds of hardware, different brands produced in their own formats. Different software also operates with its own format, with its own reference data. It's quite complex, and it requires a lot of work for a practitioner to move data around in a way that can properly service the needs of a grower. So AgGateway leveraged its wide cross-section of precision ag stakeholders to propose a collaborative solution, which is ADAPT Toolkit, which has at its heart a common object model for field operations. The idea behind ADAPT was to replace the multiple incompatible data formats of present-day agriculture with a single integration to this common object model, so that everyone could write a plugin, a piece of software that would convert from their own proprietary format to this common object model and back. Thus, we can all speak to one another with the small development cost of managing just one integration as opposed to a very large number of point-to-point integrations. This common object model is highly constrained in that it takes requirements from AgGateway's Spade and Pale projects, but it also remains compatible with the ISO 11783 Part 10 ISOXML standard and participating companies' own systems. So it's a superset of all of these different data models that have been brought to the table. Now there's at least two pairs of conflicting requirements that we had to face. First, our ADAPT work occurs in the context of ISO 11783, and in general, when working with an international standard, you're trying to be as generic and universal as possible with the concepts that you're handling. Companies are investing many resources in ADAPT, and so they want ADAPT to be usable in the different geographies in which they operate. So we have a strong pressure there to keep our work generic and not with regional data, things that are specific only to one geography, or to all of them for that matter, in that we would add things from one geography, then add things from another, then add things from another, and so forth. Now, at the same time, we know from speaking with many growers that in order for this work to be relevant and to be useful to a grower, we have to be able to support the business processes that the grower is immersed in. And for that, we need to be able to include a lot of geopolitical context-dependent data. In the case of the United States, for example, we need USDA's Farm Service Agency identifiers for farms and fields and tracts. We need EPA numbers for products. In the European Union, they have multiple codes for a variety of things, and so forth. So from there, we get the strong pressure to make our work geopolitical context supporting, if you will. And there's more. On one hand, we definitely want to be able to use controlled vocabularies. So if users are picking products and things like that from drop-down menus in their farm management information systems or their machinery, instead of just freely typing it in, then everybody can share the meaning without error. They can be very costly errors when, for example, the grower incorrectly reported the use of a crop protection product that they don't have a permit to use, for example. At the same time, all of this is happening in the context of companies that have IT departments that need to manage their budgets for deployment of new versions of standards and so forth. So we can't just go and churn out multiple versions of this work. We need to be able to make it flexible and extensible in a way that can continually accept change, additions, and at the same time, this change doesn't need to burden those IT departments. So, in summary, we need to reconcile the need to be simple and generic with the need to be comprehensive and specific on one hand, and we need to reconcile the need for controlled vocabulary and the need for extensibility. And that's a complex set of contradictions. So the proposed solution was this context item. We reconciled the contradictions by defining an object class, which we called the context item, that can be attached to various other objects in the common object model. So the context item is a key value structure. A key value structure, very simple thing, where the key tells us what the context item means by referencing a context item definition, which we'll look at in greater detail in a moment. And the value is a string that comes bundled with any other data needed to interpret that string, such as maybe a unit of measure. We also have a mechanism for nesting context items. So what does a context item look like? Like I said, a code, which is a string, a value, which is a string, which is optional because we might be nesting these things. Then a unit of measure, which is optional, and the possibility of including a temporal context via kind of timestamp called a timescope, which can bundle one or two timestamps along with what they mean. Very useful for situations where, for example, a United States Farm Service Agency farm ID might change from one year to the next. So you might want to accumulate the different farm IDs that you had for your farm, but at the same time make sure that the temporal scope of each one is captured. Some examples, you can see different classes in the model that contain context items. For example, a product, which can use an EPA number or a California product ID, a UN hazardous material code, or any other kind of data tag that is needed in any given jurisdiction. For a device, we might have a state license plate, for example. For an active ingredient, we might have a CAS number. For a field, we could have a very long list of things. You can see some examples there that range from those FSA numbers, California site IDs, and more complex things like cadastral information that might involve multiple identifiers that need to travel together. And these examples are drawn primarily from the United States, but it could be from any country. It could be from any province or state within a country. The context item system provides you with the capability of making things work for very specific geopolitical context. So here we see the context item definition. We'll go back very quickly to the context item. Remember that it has a code. That code matches the code that you see here in the context item definition. So every time you use a context item, its code is referring to this context item definition. The central idea here is that both the sender and the receiver of the context item information in any given data exchange have access to the definition so they can understand what it means. So the code, like I said, is what tells us what this means. And the context item definition provides a relatively rich definition of how the context item or a context item corresponding to that code should be entered or displayed. Value type specifies the data type of the context item value. So I mentioned earlier that these things are all packaged as strings, but this value type in the context item definition tells the consuming farm management information system how it should process that string. Is it just a number? Is it a date? Is it an enumerated item, etc.? Lexicalizations allow us to provide multiple strings in different languages for the same concept. So it allows multi-language support. Properties allow us to encapsulate values along with enumerated context items. It's a very powerful feature that enables things like, for example, in the case of the United States Public Land Survey System used for cadastral purposes. The PLSS uses a thing called a principal meridian. That's one of the parameters. So it's got a list of different principal meridians that are essentially a local origin of coordinates. And so properties allow us to bundle the latitude and longitude values of those principal meridians. The consumer of the information or the producer of the information can come get the context item definition along with its properties and see what those values are. Nested items allow us to nest this information, so we can have, for example, the multiple public land survey system context item components bundled under a single parent context item. Presentations, which specify using regular expressions how to enter and display the value of the context item. And then model scope IDs that specify what classes in both the ADAPT and ISO object models a given context item can be attached to. And this is very important. What this is doing is it's letting the user know in the originating farm management information system, for example, if a context item, a given context item, is valid for a certain kind of class. In other words, it lets you know that an EPA number, for example, is useful only for a product, not useful as a way of identifying a person or a field. But it also can tell you that public land survey system data, for example, is good for identifying a field and not a person. And this is set up in a way that can allow you to include multiple models. We've started with ADAPT and ISO 11783, but this could be extended as well so that other systems could use the context item system. Finally, geopolitical context IDs tell you where something can be used. So for example, a farm management information system in Europe doesn't have to deal with Farm Service Agency context items from the United States. We'll discuss the meaning of this a little bit more in a moment. Here we see some examples of the different context item value types. So we've got integer values, we've got floating point double precision values, we just have strings, date times, Boolean values, enumerated values, and these nested context items as well. Specific example use cases that we've discussed with colleagues from AEF, for example. We did this during several months as we were analyzing problems that we have in common, such as how to capture what the harvested commodity was in a given field operation, or what the crop is that is being grown on a field, and what the operational technique or cultural practice that is being performed might be. At first, we set out to try to find some kind of common denominator, something like, say, the European and Mediterranean Plant Protection Organization, EPO's crop list, that could maybe serve as a common ancestor that everything could map to. And that didn't really work. It didn't work because each geography or each geopolitical context really organizes data in ways that make sense to that particular context. So it's not only that there may be more or less terms in one place or another, but really the way those terms are organized hierarchically can change. We found commodity tables, this was quite common, where a group of species might be labeled alongside a particular species, alongside a subspecies, all in the same hierarchical level of the list. And that was very difficult. So Finally, we sort of gave up. We realized that it wasn't going to work out to try to have a common list for everything. So instead, we moved towards being able to accommodate each particular geography having its own list, and then setting up a mapping system whereby we could establish relationship between the different terms or between the different context item definitions. So this is a reality. AgGateway's Spade project implemented a RESTful API to provide a machine-readable vocabulary of these context item definitions. We are currently very, very close to implementing this. So I don't think it's live right now, but it probably will be in a week. There will be Swagger documentation available as well to understand exactly how to use the API. And you can search the API by model scope. So, for example, a farm management information system that's about to enter data pertaining to a field can go and search for the field model scope and see what context item definitions are available for a field. You can also search by geopolitical context. So you could search by what context items are available for a field in the Netherlands, for example. Status is the distinction between active terms and terms that have been deprecated. So we recognize that in the management of controlled vocabulary such as this, it's possible that changes may need to be made or that a term may become deprecated over time. So the possibility of a status is there, active or deprecated. Keywords, think about using AgroBoc or something like that to group terms so that you can find terms that have to do with, for example, tillage, or terms that have to do with crop protection or with organic agriculture, you name it. You can also search by time scope. So who manages this? I saw that as a question that came up. AgGateway's Standards and Guidelines Committee has created a controlled vocabularies group to manage this vocabulary. We're trying to put in place a very lightweight process based on the ISO 19135 standard for managing controlled vocabularies, so that people who need a context item definition can submit a request and get their data entered as quickly as possible, following a very lightweight burden of due diligence of making sure that, for example, the context item doesn't already exist. Like I said earlier, the context item system can be used jointly with ISOXML's feature of associating unique IDs to the locally scoped IDs of ISOXML. This is defined in the ISO 11783 Part 10 Annex E. And we have already created several examples of how this can be done very simply for non-nested context items. We may need to work with AEF and Technical Committee 23, Subcommittee 19 of ISO to make some tweaks to Annex E in order to support nested context items. But the great news here is that this enables adding geopolitical context-dependent data to ISOXML's otherwise completely generic and highly machine-specific scope without any modifications at this point. And our AEF colleagues were quite excited about that because they too have the problem of relevant in the eyes of the grower. If we can't support business process-specific identifiers, our collective relevance suffers. Another thing about the API that I failed to mention is that it's a RESTful API, which allows for very sophisticated discovery. So a machine can actually go see what's there and, like I said, know what can pertain to a different one or another class within the model. So what does all of this mean? On one hand, it enables us to move in baby steps. This can be used for other things in addition to just geopolitical context-dependent data. If there are things in the data model that we're looking at adding, for example, that we're not sure if they're useful or so forth, they can be implemented as context items first and tested and used in the industry and maybe left as context items. An important aspect of this also is that extensibility is decoupled from data model versions. So your IT department doesn't need to panic every time something is added to the list because the data model version is exactly the same. Just added something to a controlled vocabulary that your farm management information system can handle at runtime. And the beauty of that runtime handling is that this is set up so that minimal a priori knowledge is needed for use. The context item definitions are meant to be self-contained so that a farm management information system can capture or display a context item it has never seen before, just by virtue of having access to its definition and those data-driven semantics contained in the definition. So we believe that this is an exciting starting point for richer semantics in field operations data exchange, as we can use these mechanisms to tag things with very rich semantics that can then be used for complex analytics and for reasoning and so forth. There are many researchers, many industry associations that have created a very valuable controlled vocabulary that haven't seen the widespread use they could have seen because of the complexity of trying to roll up implementation with multiple companies who might not see the value of investing resources and supporting an additional controlled vocabulary if their partners are not going to be making the same investment. In this case, you just added a context item definition, and all of a sudden, everybody in the industry who is using ADAPT can use it. It also enables us to encode proprietary payloads. What does this mean? The system can be overloaded by any given user who might want to communicate some proprietary information with an integration partner. The context item system gives you places to attach data to almost anything in the model. So you can use a proprietary code to carry the data that you need. Of course, as designers of the system, we would prefer that everybody submitted context item definitions to the controlled vocabularies working group so that the definition was incorporated into the system and everybody could use it. But we understand that there will be specific needs for specific actors in the industry, and this enables those needs as well. So, is this complete? No, we have some avenues for future development. First, though, I want you to know that we are looking to publish the process for submitting new context item definitions in late 2016, hopefully in time for AgGateway's annual meeting in November. Like I said, the context item definitions are distributed through a RESTful API. We want to have the API documentation published also by the annual meeting. We hope that users will hit the API periodically to check for additions, but will cache their context items locally. This isn't something that you would be hitting all the time every time you have a transaction. And thinking in terms of future development, we will architect mechanisms to assert relationship between context item definitions, between context item enumeration items, and between any of these things and external sources of information. So this is going to enable linking context item definitions or enumeration items to definitions like the ones found in AgriVoc, or for more geopolitical context-specific stuff to AgGateway's AgGlossary, and also for asserting relationships among context item enumeration items from different vocabularies. For example, being able to say that the corn of a machine from manufacturer A is equivalent to the maize of equipment manufacturer B, and may be equivalent to the maize of the EPPO list. So that was an introduction to the context item system. We will have a follow-up webinar in a few weeks that will be focused on implementation, and where we will review the Swagger documentation and the Swagger UI that can enable you to explore the API and how to use it, as well as go over some examples of calls to the API and a discussion on how to incorporate all of this into your own systems. So thank you very much.
Thank you, Andres. Well done. And thanks to all of you who are interested in learning about AgGateway, its activities, and its resources. Be sure to check out other videos in the AgGateway Global Network video series. Take care and goodbye.